further ado, I'd like to introduce James Pardue from Ike GPS to give us our first presentation.
Well, thank you very much, and good afternoon, everybody. Thanks for joining me on this beautiful day. What better way to spend a beautiful day but then be inside, check out some new technologies, right? But I appreciate you joining me today, and we've got some really interesting and beneficial technology to share with you today. And what I'm going to do is I'm going to run through some slides, show you some examples, even do some demo work, and even I have some devices for you guys to play around with. So if you want to go outside and actually play around and use the technology, you certainly can do. You all look like a fairly bunch of trustworthy individuals, so I'll trust that you'll bring about $700 worth of equipment back. But let's go ahead and just and dive in. Once again, my name is James Pardue, and I'm Vice President of a technology company called Ike GPS. And the technology that we've built is how do I solve for being able to measure something that I can't get access to, that I can't reach, without being able to get up to it or take it down, or to be able to GPS locate something without being able to stand right next to it for whatever reason. And this technology was created, and I'd like to share with you the story about that, because like all good technology tends to have a good story behind it. The technology was created by a gentleman by the name of Leon Torenberg, who is now our CTO, who was out in Africa doing inventory of communication towers, electrical towers, and had really no good way of other than just being able to use his thumb or use some very basic technology to be able to say, that's how tall that communication tower is, or even to be able to locate it. He was walking out there with 5, 6, 7 different pieces of equipment, and he said, you know, this has to be easier. There has to be an easier way to be able to do that. And what Spike is a laser rangefinder that you attach to your tablet or to your smartphone. And what that does is allows you to be able to take measurements and GPS locate by simply targeting with a laser and then taking a photo. Everybody's very familiar with the capabilities to be able to take a photo. And so we wanted to take something that had been very complex, very cumbersome, and make it easy so that people can go out in the field and collect good data that can be analyzed, good data that could be shared easily. And that's really what Spike is all about. It's the world's first laser accurate smartphone measurement solution. Just that simple. And what we try to do is we try to make measurements quick and easy, so that all I do is I walk to the front of a building, I take a photo, and then everything on that building face I can then measure. Lengths, areas, heights. And think about that for a moment. What we've done is that we've created the capability, so much like everyone here is familiar with doing, about measuring from a satellite image or an aerial photograph, but we figured out how to do that and turn it on its side by using a digital photo. That's really something that's quite exceptional. And when you think about it from a geospatial perspective, it's a new type of attribute that can be added to points, lines, and polygons, where you have a photo that has measurements to it and can always be loaded up again and has sufficient metadata that you can measure it again. So one of the interesting things is I was walking by, and I don't know if you noticed the wall that was behind us, where it had all these things like gas stations and all sorts of other features and objects, schools and other types of infrastructure. Each and every one of these things has the capability to be measured with a Spike simply by standing in front of it, taking a photo, and then you have all sorts of information that you could then measure the feature within that photo. And to demonstrate that a little bit more, what I'd like to do is that show you a short YouTube video that does a very nice job of sharing this. And hopefully I've set this up right. Except somebody turned the sound off on the thing. Got it?
So many businesses and everyday tasks. Yet taking measurements is often a difficult, lengthy, or expensive process. With Spike, the way measurements are taken and shared has changed. Spike allows you to measure an object simply with a snap from your phone. From that photo, you can capture real-time measurements, including height, width, area, length, and target location. The time to measure objects is reduced from hours to minutes, and all you need is Spike and your smartphone or tablet. Spike has a built-in laser rangefinder and Bluetooth, which makes it all work seamlessly with your smartphone or tablet's camera, GPS, compass, and connection to the internet. With Spike's easy-to-use app, take a photo of the object you want to measure. Using the app's measurement tools, you can record dimensions on the spot, or wait until later. You'll be able to reference your photos and measurements at any time, in case you want to make changes or take additional measurements without returning to the site. Instantly ship.
Oh, well, that's the issue with doing a live demo, isn't it? I wonder if I lost internet connection. Well, we'll just give up on that video, but you get the idea of how the technology works. And I'll jump right back into the slideshow here. So I apologize for the fact that that YouTube video didn't complete. So just to recap, so what the solution in and of itself is the use of a smartphone or a tablet, the Spike app, which is free, the Spike device, which retails for $499, and the will and the need to be able to go out and be able to measure things within the world and be able to GPS locate those things. Some technical specifications. We work with iOS and with Android. It's a small size and weight, so it's very easy to be able to take out into the field. So if you're doing remote data capture for long periods of times, you have to hike and do all those other things. It's a pretty low load. The laser rangefinder works to a distance of 200 meters, very sufficient for a lot of applications that are out there today. And the accuracy of the laser and the measurements that we do, because everybody's always wondering, well, how accurate really is it, is plus or minus 3%. So what we say is that if the real world measurement is 100 feet, well, if we measure it at 97 or 103, that's within the range of tolerance for us. So that's an important thing for you to know in your field craft out there is that if you need a precision measurement or if you need a precision location down to the centimeter level, this is not the product for you. And it's not intended to supplant those types of technologies. Survey is great. By all means, go out and do it. But what this solves for is that how do I get, rather than two people out with a Trimble or a Leica or a $10,000 or any $10,000 survey device that requires $10,000 worth of training, how do I do that? I can do that, or I can send 30 people out in the field collecting data and doing it very well and collecting types of information that's never been available before and be able to do that in a training of about an hour. So how do you get more people out in the field? That's an important thing for us. And use of the Spike is pretty simple. I just attach it to a phone. I do some simple calibrations for the laser because we have to make sure that the camera and the laser are somewhat aligned. It has some knowledge about that, as well as that the compass within your phone is aligned. Then it's just a matter of just launching the app, taking a photo, doing some measurements, and then you have some choices about how you can publish that. You can export that as a PDF or a JPEG. Very simple, non-geospatial types of formats, but for some, that's all you need. For example, we have a number of city inspectors today that when they go out and they inspect signage or inspect, or they measure the length of a new fence or the size of a new wall, any types of those things, they just want to take a picture, do a measurement, show the measurement on the photo, save it to a report, off they go. That's all they want to be able to do. But then there's others who have more geospatial requirements, such as, and that's why we've created an XML file format as well as a simple KMZ, things that collect a series of the geospatial metadata so they can be used for analysis later. So we give you a number of choices for how you want to be able to store, publish the data sets. But the most important thing about what we do and makes us so different and makes the technology that we do that is patentable for us is that we use that laser rangefinder, and we use it to be able to correct for the distortions of the image based upon angles or other factors that incorporate themselves into an image. So we have to be able to have that somewhat of an accurate laser distance, as well as using the compass, the inclinometer, the GPS within the camera. Within the iPad or on the iPhone, so that we can make corrections, to the image itself. And you can tell from the video itself was one that was pretty commercial, right? Which is that it's really tied towards people that are doing measurement on a daily basis in construction or signage or digital graphics. Because the interesting thing is that we started out doing things with a big device called an Ike for utilities, and that was great, except for the fact that it was $10,000 to $13,000, and it did that job of utilities and doing polls and all those other things very well. But what we wanted to try to do is that how can we empower the everyday person to be able to go out and collect this type of information so that it could be used for analysis, so they could go out and do certain types of field work. And so the first groups to adopt the technology was construction, because you can see how this makes sense to them all day long. I walk to the front of a building, I take a photo, I can measure gutters, I can measure siding, I can measure fence, I can do whatever, all these other things. But then that started to migrate, and one of our first early adopters inside of government was defense and intelligence agencies. Because they love this type of thing, because they don't have any way to really be able to measure things from a distance. And for them, distance is important, because distance and cover tends to mean things like safety, right? So the capabilities to be able to walk to the front of a building, be able to take a photo like you see, and be able to measure doors, be able to measure windows, distances of how much rope do I need from the top to get to that window, or how much tactical ladder do I need to get from the bottom to the top. Those types of things doesn't exist. And if you look at the right-hand side here, or my left, you'll see an example of a KMZ output. Just that capability to say, I'm here, this is where I'm looking, there's the target, and here's a picture of the target. And then be able to share that to your command, to share that to everybody else within your unit that has that type of visualization capabilities. They don't have any ways of being able to collect and share that type of information. So using something like a Spike is very exciting for them. But since then, we've started to grow and move into other applications, such as in the National Park Service. National Park Service is now going out and documenting locations and measurements of historical buildings on their property. They're required to do so. Each park is required to do so on a 5-year basis. Spike is going out with these because it's lightweight, it's compatible with devices that they're already using in the field. And now we're working with companies like Esri and Pitney Bowes, others, to be able to integrate how our data is collected and seamlessly get it into their software systems. Because we all know, being in the field, right? How many people in here have been out in the field before? Pretty much everybody, right? What happens in the field is great. Entirely different when you bring it back, and how you have to work with it. And every day in the field is weeks back in the office, that type of thing. Well, we're trying to cut that down by integrating in with different software vendors to be able to make those things happen just a little bit simpler. But what we'd like to say is that what Spike does is that we turn a smartphone or tablet into a geospatial multi-tool, because we open up a lot of capabilities that don't exist today in a smartphone or a tablet as it relates to geospatial field data collection. That photo measure capability you've heard me already talk about, right? So I take a photo and I measure things within the photo. That's great, that's wonderful. But hey, what happens when I can't fit everything within the photo? Like a bridge or something else. What do? Well, we created something that's called point-to-point that allows people to be able to measure things in 3D space, so that if I wanted to measure the distance between that wall and something on that wall, I take one photo, I take a second photo, it gives me the measurements between those two things. Once again, the capability to be able to measure that type of stuff, very interesting to DoD and Intel, right? So and also in law enforcement. We have law enforcement using this now for surveillance. What is the distance between that door and that car that person is likely to try to get into? Or how far is it going to be between ground cover, between that side of the building to where I want to send my people over to? But DOT loves it also, because what is the distance between this corner of the bridge and that corner of the bridge? They certainly can use survey tools to be able to do that. But sometimes just being out there to have just the good enough tools to be able to sit there and just give me a general idea about what that's going to look like. Plus or minus 3%, way better than anything they have in the field to be able to do that today. And that's really what we're striving for, is to open up measurement and location and making that a daily part of how those things are integrated into the geospatial applications. But we also find people just like having a laser rangefinder on their phone or on their tablet. It's kind of cool. How far is that? Now you can look it up. It's just neat, right? Not for all that useful, but it's just neat. But to be able to collect GPS locations easily, with an offset. So so this morning I was spending some time in the Harvard Yard to take some photos to be able to use in the demo today. We'll see if the moderator will let me do that if I run a little long. But what it does is creates that GPS location of that asset where it actually sits with that offset. Because today, if you go out with a smartphone or a tablet and you take a photo, it drops a GPS point where you're standing. Well, that's not great if you're doing mapping for secondary cities and something happens to be 50 feet or 100 feet away. You really like to have it just drop right where it is, and so that reduces your time back in the field. That is one of the things that we do. But able to publish and collaborate and distribute that data quickly and simply, and also to make that data discoverable. We've been working with a company called BAE for some law enforcement applications where they were using it for planning for special events. And they were able to figure out that, show me all the things that are designated as events that have measurements tied to it with a spike photo that are less than 12 feet. And then that pops up. And so now you can see where you might have to do some additional work to make some changes. The other nice thing is that I can measure on the device when I take the photo if I want, or what I can do is I can save it and I can send it to somebody else, right, that might have the Spike app loaded. You don't need the Spike, but you just need the app. Or I can send it to a central location where I need a little bit more real estate to be able to do my measurements. I'll show you how those measurements are done here in a little bit, but we all know that sometimes working with tablets or phones in the field are a little problematic. For example, glare. Glare is terrible. But also sometimes about just when you're just making annotations or dragging things with your fingers, it's just nice to have some more real estate. And so you have those choices. And you can always go back. So if you took a photo of something and you were just trying to do some measurement, or maybe even measurement wasn't important at that time, just the fact that you took that photo and you made it a spike photo, you could always go back and measure it. So for example, if I was measuring the top part of that sign for, say, King Soopers, but I wanted to measure all the other signage below, I could always go back and do that if that was something that I was interested in doing. And you have a number of different choices about how you want to be able to export that. From the mobile app, you have JPEG, PDF, KMZ, as well as the XML. But from the cloud, you can export as a PDF. You can just send a URL link that links back into the cloud, or as a JPEG. So you have a number of choices based upon your workflow or how it is that you would like to be able to work with the data. So what I'd like to do is start to get into some examples here so you can really start to see kind of what a spike photo and what the spike outputs really look like. So you can start to get some application ideas for the things that you might be doing as it relates to secondary cities or anything else that you might be interested in doing. One of the key things is to be able to assess and evaluate, to be able to get information about hard-to-reach objects. Sometimes you just don't have access to it, either because there's a fence in the way, or maybe you're just too lazy. There's any number of different things why you don't want to get there, or maybe it's just more efficient to sit here and go, I'm going to collect information about that tree, then that tree, and just go bang, 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 do it all from one spot. That's great for efficiencies. But to be able to safely catalog and capture remote targets, we talked a little bit about this one with DoD and Intel, but as a KMZ output, the location of the individual, the direction that they were looking at on the target, and there's the photo of the target. Here's an example of a screenshot where measurements are being done right on the screen, but that's for urban and tactical types of operations, your DoD, your Intel, your law enforcement, but also, we're seeing a lot of people doing this from a historical standpoint. So you heard me talk about the National Park Service, but we have a number of cities and counties now that are starting to work on this for historical heritage sites, for architectural renovations of designated historical sites, because they need to create real proof about this is how this existed, and then they submit plans about how they're going to change it. And to be able to have photos for which they submit on their applications that says, say, these are the dimensions of the existing doors and windows and eaves and all these other types of things, that's a great help. But as it relates to to be able to capture information about features, it's a whole different layer of features to be able to capture when it comes to secondary cities. For example, the dimensions of buildings, or to be able to engage into creating tiles and things with georeference photos from a spike photo for 3D buildings and other types of applications as you go to be able to build this out. It has the capability to create a tremendous amount of information about any single feature, object, or piece of infrastructure or asset that you would want to be able to grab information of. We have a number of federal agencies that are using our application now for energy studies, because we give you the capability to be able to sit there and say, here's the face, I can measure, this is the stone pieces, these are the pieces that are windows, be able to calculate those areas, and now I have some measure of stone to glass that I can do some energy studies with. But we also have DOTs that are out there using this quite a bit. Everything from location of potholes to doing damage and assessment in infrastructure. Now, once again, this is not something that you use to be able to calculate the volume for something that I'm going to use to patch that, but certainly gives you some indication of this is what I saw, this is the indication of that damage, this is about the relative size of that damage that I saw when I was in the field. But just to be able to capture just the information from anything about poles, anything that you can think of. We also have a number of assessors that use this, because once again, this is a great tool. I go out to the front, boom, I take a photo. I have information about the condition of that house, which are things that are not always captured in the types of forms that they collect today. But also to have the capability to sit there and say, well, the grass is looking a little unkept in this photo. Perhaps code compliance needs to be informed about those types of things. Things that only can be picked up with photos, that can be shared, that can be put into an archive, that not only yourself can use, but others can use to be able to go back for reference at any time. And we've also been used quite a bit for disaster response as well. We've had people take Spike, go out into the field, and be able to document disaster response for FEMA, and be able to speed up that funding process for getting funds back for emergency disasters by significant amount. There was just a couple of years ago a tornado in Mississippi. County that used Spike got their money in 6 months, which was almost a record for FEMA. 4 years later, there are still counties waiting to get their funds because they didn't have that capability to use Spike to be able to show this is every single building that was damaged. Here's a record of that. Here's some measurements of the piles of damage and other things that go along with it. So there's empirical data to go behind that. So, and that's really a testament to part of the solution is the type of information that's provided so that people have comfortable with what it is that you saw in the field, that you report and that you provide. Because you have location and you have those measurements. Anybody ever go out in the field and then come back and then forget where you actually took the data? And didn't know exactly where to place on a map? You guys are kind of fibbing. I know you have. I have. I used to work for the National Wetlands Inventory. There's been a couple times where I was taking notes of some place that I thought that I was and I really wasn't. All right, so so having that, all those things, combined, the photo, the measurements, the location of knowing about where I am in the field and people communicating that back with efficiency is really, quite nice. And we've also started working with the EPA as well. So they sometimes don't work in the nicest of places and don't work next to the nicest of things. So to be able to GPS locate from a distance of 200 meters with something like that coming out of a pipe is really kind of nice. But also it gives them a photo record of the of the types of conditions in an area. I'm going to share a couple of photos here on point to point to give you some examples of what those outputs really kind of look like. And then I'll jump and show you some examples here on a demo and actually do some measurements on Spike, in the cloud, in our cloud solution. But the point-to-point is just simply measurement between 2 points in 3D space. So sometimes it's useful to be able to sit there and say, what is the distance between that building and that hazard? So insurance companies are very interested in this, right? If anybody here is from Colorado, you have a very good idea about what defensible space is about. And what defensible space is about is the distance between other flammable materials in your house. This is a way for them to be able to go and inspect that and be able to measure that very quickly, other than to be able to run a tape measure and do that, right? I just walk, I take my 2 points, and it gives me that photo. But also vegetation assessment, but also measurements of right-of-ways. Right-of-ways is a serious issue, across the United States as it relates to, because right-of-ways are sold, managed, and you're responsible for them. So knowing whether things are encroaching on them and knowing what that measurement of that is, or knowing whether somebody has violated your right-of-way setbacks in any shape or form is something that's important from an application and a state and local government standpoint. So I'm going to transition over to doing some photo measurements here in the cloud. But as I do, does anybody have any questions?
Just two quick questions. Does it work indoor?
It does work indoor, but it will only work in the sense that you need at least 3 feet of distance away to be able to work. But it is optimized for outdoors. So we do actually create a product that is optimized for indoors, and it's actually something that we OEM through a company called Stanley Black & Decker. So you can go to Lowe's or you can go to Home Depot today and actually buy a version of this to be able to do construction stuff internally for inside, like paints and things like that.
And how does it deal with the camera distortion? Because I expect there's some kind of calibration process also to know the distances that you're looking at in the camera. But then there's also lens distortion. So does it have a reference database of all of the cameras of the possible devices?
It does, because what's nice is that every manufacturer creates some, that type of information, publishes that information that we then use into the photogrammetric solution. Because is it the most robust photogrammetric solution in the world? No, of course not, right? But it's enough for us to be able to correct, within the image. And you'll see how we do that here in just a little bit if I can get back here on the web, which was one of the reasons that my YouTube video quit.
I just want to make a quick announcement. We are going 15 minutes longer, so you have another 15 minutes to finish your presentation.
Okay.
Because we started 15 minutes late.
Okay.
So the next presentation will start at 2:45. Yes, at 2:45.
So I don't have to talk as fast. Okay. Thank you. Okay.
Are there any other questions?
Which of the features require an internet connection? Is it all of it, or can it work without internet connectivity?
So it works in a disconnected environment. The only thing that is really affected by whether it's connected or not happens to be if you're working with a device that does not have a GPS chip within it, that requires location as a part of that through wireless. Most phones come with chips now. A lot of the new tablets do, right? So, but if you're, for example, if you're using one of these older ones, right? So, if you're using like an old version of an iPad, those didn't always have chips in them. So you have to be cognizant that you have chips. This is a number 2. 1 and 2 don't have chips. I believe 4 does, and a lot of the Android tablets now have chips. So it's just that's the biggest indicator. So if you want that type of GPS location, make sure you got a good chip in the device.
I actually have a question. I was curious if this is a device that anybody can use. It seems like it's really for surveyors or people who have that kind of surveying experience. And so I was wondering, how easy is that? Is this to adapt to, you know, for example, a neighborhood group who wants to take measurements in their neighborhood for different purposes?
Very, very good question. So what we try to do is to simulate the action as much as taking a photo as possible, so that people would be comfortable in doing that function. Because there's really two components to what we do. One is the actual act of taking a photo, and then there's the act of measurement. So the act of taking a photo, if you can find somebody that knows how to point a laser, right, and if you guys, like I said, you're free to play with these devices for the rest of the day here. And I'll even be around tomorrow too. So if you want to tap me on the shoulder and grab one, or just go outside with one later on today, you're more than welcome to do so. But there's actually a laser reticle that you might have seen in some of the slides where you can see it. So as long as they know to point it and click on the object for which they want to measure, that's what's important. And so, because they don't necessarily have to measure, right? So if you're doing something as part of a public outreach, or that type of program, just giving them this device and then having them attach it to the phone, and probably the calibration is probably something that you would probably want to do yourself. We do have some online videos that people can follow and do that instruction. But once the devices are calibrated, they're good to go. You can hand them to anybody to be able to use. Measurement takes a little bit of training, but I would say that both the calibration and the measurement training you can do in under an hour. So all doable within an outreach type of situation. Any other questions? Yes, ma'am.
So if I understand correctly, you just take the photograph sort of once with the laser pointed at your target, and then kind of after that, then you can do your measurements at any time. It's not like you have to be looking at it at the same time and measuring at the same time, right?
Correct. Right. So
So
once you take the photo, then you have
just
something. Then you can
away,
measure.
yeah,
Right.
at any time.
And there are a couple of best practices as with anything else. Right. So for example, because we are doing rectification to the image, you want to try and minimize to a certain degree the angles. Right. So we can handle from nadir or 90 degree angle up to 60 degrees out. But then after that, the angles become so extreme that it makes the measurements that we do not all that useful anymore, because you don't have that much of a confidence in it. So let me. Oh, yes, ma'am.
Sorry, just a curiosity. Thanks. So, when you take the picture, let's say I take the picture of a facade of a building, then what is the level of detail that I can get in terms of the measurements? Like, so I have doors, windows. Can I actually see other smaller details or windows? What are the details of the measurement that I can get with one photo?
Well, I tell you what. I think the best way is probably just to show you, if I could, right? And if I don't completely answer that question, you're free to come back and ask me after I've left. Okay, great. No, we can go back and revisit that, right? So the first one that I'm going to open up here is one that's really easy, and then we'll go to something that's a little bit more challenging here. So what you're looking at here is 29 palms. So as far as the types of features that you can see, right, there is some limitations to what you can see based upon the camera, right? So we're sitting here at a distance, right? I can zoom in, and the cameras these days are pretty good, right? So I can see quite a bit. That big red dot that you see right there, that's the laser. So that's important that I know where the laser is for reference, because the laser sets where the face or the scale of the photo is going to be set. So just like in a aerial photograph or a satellite image, once I set the scale, it's done. That is tied to that. There's not much that I can do. And so knowing where that laser hits, you want the laser to hit the target that you're going to want to measure. So we're going to measure this building here. If that laser had been over one of these windows, I know I'm now measuring deep down, in there. So that's not something that we want to do. So to the gentleman over here who's probably wondering how in the world do we do this alignment and whether we do it on the fly, we don't really do it on the fly per se, but what we do is that we create an area of where we make an alignment so which we change all the pixels within the photo, or that we draw that to, right? So this is something that I've already drawn on here because I've used it before, but basically I use the screen to be able to set that, and then once I've set that, I can then be able to create my, where I can be able to do my measurements, so that if I wanted to then be able to do things such as various links or areas or cutouts for that example. So say I want to be able to do this here, right? I can go ahead and do that, and I can do that relatively simply. If I want to do links of any types of different sizes, I can go ahead and do this. I'm going to do it really quick just because I've been told I have 5 minutes left. But I can use different tricks to be able to sit there and say that's relatively about the ground, 23.7. So those are the types of measurements that I could do. And then when you combine that with products that are out there, such as like Esri Collector or Survey 123, you can make this as part of your forms where you'll be able to put those measurements in and then be able to bring those into a GIS. We are currently working on an app specifically for Collector and Survey 123, so that you can be in Collector or Survey 123 and just go right from that and say, I want to take a spike photo, take the photo, and then be able to pull the information that is collected within a spike photo, either there in the field or later. So that's part of the workflow.
How are the measurements being recorded and saved? Is that something that you set up in advance? Oh. Just wondering about saving the measurements once you've done them. Where does that get sort of stored and then accessible?
So, so depending upon the output, right? So if it's a JPEG, it actually goes right on the photo. It'll actually show the measurements of the photo. If it's a PDF, it creates a PDF report with all the measurements there. If it's an XML, which is the most geospatially mature, I would say, of our outputs, it has those within a series of fields that can be harvested and put into a GIS. And then there's a KMZ. And the KMZ is a little bit different. In that it doesn't actually have the measurements tied to it. It just collects 3 basic pieces of information. I'm here, target's there, here's a photo of that target. So you have a number of different choices because not everybody knows how to manage an XML. So we try to mix that up a little bit so that it's appealing to as many folks as possible. So I was just out here at this morning, and I shot. I was out here at the art museum, and I like this because it demonstrates a couple things. So you'll notice that I shot the sign because that's what I want to measure. Once I create an alignment with this, and I set it to here, it's set to the plane for which this sign is on. So what that means is that if I'm in the field and I want to be able to measure the sign plus the face of this building, I need 2 shots to do that because I've essentially signed the pixels to a scale that this sign is on. So that's important to know. And it's one of those things that are sort of tied underneath best practices and that type of thing. Can you do measurements from here to here? Yeah, you kind of can. You kind of playing around with the accuracies a little bit, but it'll give you a good general idea. And this is something of where you've flown halfway around the world, and just for whatever reason you need to know the distance between that sign and that edge. That's good enough. And when especially considers you have no other way to doing that unless fixing that unless you send somebody else. So I say this from time to time, and people sometimes cringe when I say it, but when it comes to this type of location and measurement, when it comes to location, we've created a solution that's really the absolute best good enough solution you can think of today, because there's nothing that allows a measurement within a photo, within a handheld digital photo. It does not exist, and we figured out a way to make it inexpensive, put it in the hand, and make it as simple as possible, so that more people can go out and collect field data, and that you can generate field data that's useful in ways that no one had ever thought about before, about where you can create those measurements and store them as an attribute for a point, line, or polygon, but also create efficiencies that have never existed before, so that as a part of, say, some outreach that you were doing where you landed in a town, you're going to do some secondary cities mapping, very basic stuff. We're going to do these 6 blocks, and we're going to collect photos of every building and have the GPS location of every building and have the capability to measure just different things on there. That's an incredible capability, and to train people in less than an hour to do that is really quite exceptional. And that's really what we've intended to do here, is to build a technology that's easy to use, that delivers good data, and data that people can use to be able to, and I'm going to drag out my words until you put up the stop, because that's the kind of guy I am. No.
I'm working with you.
No. But anyway, so anyways, you can see I like to have fun during my presentation. So that's my presentation, for today. I will be around here this afternoon, as well as later on tomorrow. I will have these devices with me, so if you want to just pick them up and play around with them, take some shots with them, you're more than welcome to go ahead and do that. For any other information, you can look us up on the web, and you can also request to talk to us. And if you see an opportunity where our technology would be of benefit to your programs, please think of us, reach out, and we'll see if it's a good fit. Thank you very much.